After firing, the bullet moves in the forward direction due to the force exerted by gun on the bullet. While the gun is moving out, while the bullet is moving out, the bullet also exerts force on the gun. So the gun also moves in the backward direction. Bullet moves in the forward direction, gun moves in the backward direction. In this situation, in this motion, no external force is applied. No external unbalanced force is applied. So we can say that the total momentum before firing, total momentum after firing are equal. Now after firing, the momentum of the bullet and the gun, that is total momentum. Total momentum, it is total momentum. It is equal to mv plus mv. Since no external unbalanced force is applied, total momentum before firing and after firing are equal. Therefore, it is mv plus mv equal to 0. Now, from this, we can obtain that if we have the 4 variables, if we know 3 variables, the fourth can be calculated. Suppose it is the v equal to, that is velocity of gun, equal to, that is minus mv upon capital M, mass of the gun. So what does this minus represent? The minus represents velocity of gun is opposite to the direction of velocity of the bullet. The bullet is moving in the forward direction, so the gun moves in the backward direction. This is happening practically whenever a gun is fired. A gun, rifle, any or a cannon, anything is fired. In that condition, that the device also, if it is the case of gun, the gun moves in the backward direction. If it is a rifle, then the rifle also moves in the backward direction. In every case, if anything is fired, if shell is fired from cannon, the shell moves in the forward direction, cannon moves in the backward direction. So, and that velocity of that gun can be calculated by using this relation. Negative sign indicates only the gun is moving in the backward direction. It will not affect the numerical value. This is one example. Now coming to another example. One more example. So this can also be the example for Newton's third law of motion, because here also action and reaction. Action and reaction, the force with which the gun is moving in the forward direction, with the same force, it also exerts on the gun, right? And the second one is for the law of conservation of momentum. Suppose we have two objects, or we can take the example of a man and a trolley. This is the surface, right? On the surface, a man is standing and a trolley is placed. Right? This trolley has some mass and the man is also having some mass. This is the trolley. Let us assume that in the beginning, trolley and man are separated. Now we suppose the trolley is moving with some velocity, and the man is also moving with some velocity v1, or you can take it is u1 and u2. Initial velocity. Mass of man is m1, mass of trolley is m2. Now we assume these two are the objects in the system, man and a trolley. Now they are separated. Here we can assume that the man is moving with velocity somewhat greater than the velocity of trolley. Then what will happen? After traveling some time, definitely the man can catch the trolley and jump on it. And jump on it. After jumping onto the trolley, now you see both trolley and man are moving together. In this case, we can take their velocity common because they are moving. The man is in the trolley and they are moving together, so their velocity same. Now here the mass of man, mass of trolley, and we have the two things before jumping on the trolley and after jumping onto the trolley. Here also no external unbalanced force is applied, so total momentum before and total momentum after. So before the total momentum is, it can be total momentum m1 u1 plus m2 u2. Here the total momentum you can write m1v plus m2v. So it can be written as, since no external unbalanced force is applied, m1 u1 plus m2 u2 equal to m1 plus m2 into v. And this is the velocity. This is the velocity with which both are moving together, and that we call common velocity. So from this we can find out what is the common velocity. So m1 u1 plus m2 u2 upon m1 plus m2. This is also the example for law of conservation of momentum. Like this, we can discuss many examples. For example, two players. Let us take hockey players. They are chasing a ball. They are chasing the ball from different directions. On reaching the ball, they collide with each other and moving together after collision. They are colliding. After collision, they move together. In that case also, we can find out with how much velocity they move after collision. That can also be calculated with the same relation, right? So this is about the law of conservation of momentum. Now it is the last part, the examples of conservation of momentum discussed, and in the next session we will discuss about the question answers of these chapters.